Okay, greetings. Thank you for joining us. My name is Lance Harry. I am the president and CEO of FireAway. We're going to talk to you today a little bit about special hazard fire protection. I am coming to you on behalf of the Fire Suppression Systems Association, and we are a nonprofit trade organization. And we'll talk a little bit about that in a few minutes. So let's jump right in. So we're going to talk a little bit today about special hazards. I'll give you a quick overview of what that looks like. What are special hazards? Some of the applications. We'll talk a little bit about the different systems involved in protecting special hazards, some of the components associated with that, some of the technologies that are available in special hazards protection systems. Talk a little bit about codes and standards and what they entail and what codes and standards are out there. And we'll talk about relevant regulatory activity. We do have some interesting regulatory items that do impact our industry and thus could impact folks that are looking to purchase these types of systems. Quick conclusion, and again, a quick overview of FSSA, but that is the program. So let's keep things moving here. So what are special hazards? Excuse me. Really any area containing equipment or processes that are of particularly high value. There are a number of different examples of this, and we'll look at that in a few minutes. But really anything that in a building environment or any process that might contain equipment or have processes that are very high value. Might contain unique or irreplaceable assets. We'll talk a little bit about what that is. Pretty straightforward, pretty obvious what that might look like. Really any area that the revenue being produced is as valuable or even greater value than the equipment itself. So things like data centers, transactional environments where the process that's going on is actually generating enough revenue or so much revenue that you can't interrupt that process, or you don't want to interrupt it if at all possible. I mentioned data centers, any telecommunications type environment, server environments, server farms, computer rooms, all kinds of telecommunications hubs, things like that are essentially high value asset areas and certainly would be considered an area you might want to protect with a special hazard type of system. I mentioned irreplaceable assets, museums, galleries, archival type environments. Also, one type of environment that is very commonly protected with special hazard systems would be old buildings or of heritage type of environments where they're just not replaceable and can't be rebuilt or something like that. We mentioned processes quite a bit. So this is a good example of a process environment where it may look mundane or sort of commonplace, but depending upon what it's controlling and what environment is occurring around it, the infrastructure that it's supporting might be an area you would want to protect with a special hazard. A good example of this might be water treatment environments, desalination plants, where you might be in an environment where water is scarce and the process itself and the output of that environment or that facility is of such value that it just can't be replaced. You need that to be up and running all the time. Healthcare environments are a good example as well. This one depicts a surgical suite where you want that to be available all the time. Other examples might be MRI facilities where an MRI is of such value that you don't want that to be damaged. You want that to be up and running all the time. Not only is the equipment very valuable, but the revenue that it generates can be very important to the business. So you want that to be protected and to be available all the time. Another one might be healthcare records, might be protected by HIPAA. Those have to be available all the time. I think the limit on that is 7 years or something like that. But essentially, you want those types of records to be protected. And that's a pretty common application for these types of systems. And then the last one is a little bit newer in terms of the types of applications that these types of systems protect. You see here depicting an energy storage environment. So energy storage has become increasingly more valuable in that it's used in conjunction with renewable energy sources like wind and solar, where you're producing energy, but you may not need it right away. So you're storing it for some period of time and then delivering it to the grid, to the building, to a residential environment when necessary. particularly when the renewable source is not available. If the wind is down, or obviously the sun is down, you have that energy storage capability that could deliver energy in high demand timeframes. So this is an area that is and is growing rapidly and is currently being protected by special hazard type of systems. So what is a special hazard system designed to do? Well, it's a number of things. Quickly detect an incipient fire or a heat condition. So we want to protect and detect the potential incident very early on. The idea for that is if you can detect it early and suppress it and extinguish the potential fire early, you're minimizing damage, you're minimizing downtime, which is one of the fundamental objectives of these types of systems. So not only are you trying to detect the fire early, but you're trying to suppress the fire early, particularly when sprinklers may not be the best first line of defense, if you will, for your fire protection strategy. Now, in many cases, these types of systems are used in conjunction with a sprinkler system. And the reason for that is mostly code driven, particularly here in the US, where codes require that you install sprinkler systems in most occupied buildings. That doesn't necessarily give you the kind of protection that you want in these types of high value asset areas. So many times customers, end users elect to install a special hazard system along with the sprinkler system in order to detect the fire early, try to suppress it early before a sprinkler system might even go off. We're obviously there to protect people. These types of systems certainly provide life safety. The earlier you can detect and suppress a fire, the safer it is for the occupants. You also want to evacuate the facility or that particular space as soon as you can if you know that there's a fire potentially that's going to occur. And so these types of systems allow you that early warning and also early suppression in order to egress out of the building or out of that space. We mentioned mitigating business interruption. Certainly, that's an area that we're trying to protect that area early, detect the potential issue, suppress the fire early, mitigating the potential interruption to the business and the process that's occurring within the protected space. And you certainly want to limit the loss of assets and information and the revenue generating capability of that facility. One of the interesting parts of these types of systems is it requires very uniquely trained and qualified people to install, to design, to service, all of those things. Our organization is actually made up of a very large number of these types of organizations, and the folks who run those organizations own them and run them. And so we have quite a large network of people that are involved in the contractual side and the actual hands-on installation and service of these types of systems within the FSSA organization. So this is a good depiction of what a typical special hazard system might look like. Starts with a detection system, as we mentioned in the previous slide. The blue lines here replicate or represent the detection type of system. The small circles there is really a traditional smoke detection type of system. We have detectors both in the subfloor or under the floor, as well as in the above floor or main space of this type of a facility. That's pretty common in a data center type environment or computer room environment where you have that sort of subfloor. You want detection and suppression in both of those environments in those types of facilities. The detection system is wired back to a central control panel. The control panel is typically dedicated to this type of a system. So this suppression release panel is connected directly to the system and controls when that system might be activated. In most cases, this type of panel would then be tied back into the larger building fire alarm panel and communicate with it to determine when that system might go off or impending issues in this particular area. Also connected to the control panel would be notification appliances. You might have horn strobes, you might have buzzers, alarms, all kinds of things to indicate a activation might be upcoming or that an activation has already occurred. We also have the agent storage containers. We're going to take a little bit closer look at that in the next slide. But this is a fairly common kind of traditional view of what agent storage containers might look like. You've got pressurized cylinders. In this case, you've got the red one that contains the actual agent. You've got the gray one that contains nitrogen that pushes the agent through the distribution piping network, which is depicted here in red, and then finally out the nozzles at the end of the pipe network, most commonly brass, but could be stainless steel or a variety of other materials, but most commonly brass. If you look up in the ceiling of a data center, very often you'll see these types of nozzles installed at the ceiling level. So as I mentioned, a couple of pictures here. Traditional gaseous systems would look something like this, where you'd have agent storage containers, pressurized containers that are stored in a bunch. Could be 1, 2, 3, could be a whole bank of cylinders, depending upon the size of the space that you're protecting. You could actually install these cylinders in the protected space itself, or they could be installed in a remote location, and then the agent would be piped into the protected space, as we saw in the previous slide. We also have a group of what I call alternative systems, which are slightly different than your traditional pressurized storage or central storage containers. The top left, you have water mist. So those are very small droplets of water that produce a very high surface area, which enable the absorption of heat and could put fires out fairly effectively. That system is used in a variety of applications. You see here, it's actually an aircraft hangar, which is a nice alternative to a traditional sprinkler system in that type of application. In most cases, you can use anywhere between 75 to 90% less water than you would in a traditional sprinkler system with a water mist system. On the right there, you see what's called a hybrid system, which is kind of a combination of water mist and an inert gas system. So it uses both water mist technology as well as an inert gas discharge to reduce the oxygen in the space just enough to help the water mist put the fire out. In the bottom left, you see a kind of a hybrid system as well. This uses a storage container of traditional gaseous agent, but the detection system is a little bit different. The red depicts a pressurized tubing that can burst and then allow the system to discharge through the yellow tubing into the protected space. In the bottom right, you have an aerosol system, which is a slightly different type of system, does not use a centrally stored pressurized container. These are small canisters that are installed throughout the protected space. Each one would be discharged at the same time to produce enough density of aerosol to put a fire out. In this case, we see it depicted in a energy storage container, which is a fairly common application for aerosol systems, as well as several other types of systems. Excuse me. Just to give you an idea of the landscape of the different types of companies and different entities involved, really this is a good look at the different types of organizations that are involved in the FSSA organization as well. You have traditional chemical manufacturers. So these are sort of large name chemical companies that are producing the types of chemicals that are used in these types of applications. They would partner with a system manufacturer who puts together all the different components, like the storage container, like the valve, the nozzles, all those types of things go together with the chemical to produce an actual system. Now, we also have a group of system manufacturers who do not use chemical agents, more traditional supply component manufacturers, component suppliers, put together all the pieces that are necessary for a system. Our company falls into that category. We don't partner with the large chemical manufacturers because we don't need that. But both of these types of system manufacturers will then in turn partner with the installers or the highly specialized contractors that focus in this area or are experts in the special hazard fire protection world. Now, you might hear these folks referred to as ESIs or engineered systems integrators. Sometimes they might be referred to as VARs or value-added resellers. That terminology is more an IT industry, but it's a pretty good depiction, excuse me, of what these types of companies do. And in our world, on our side, we call them distributors, but they're really more than distributors. A lot of people immediately think of a warehouse with a countertop and a huge bunch of parts in the back that that's a distributor. Well, these folks are more than that. They certainly are experts. They're trained. They install the systems. They maintain them. They service them. So it's a fairly unique group of companies that fit into this category and are capable of doing that type of work. Now, when it comes to a project, you might have all sorts of entities involved. You might have general contractors. You might have consultants. You might have insurance companies. You might have the AHJ, which is short for Authority Having Jurisdiction. And those folks, as well as others, excuse me, make up what we would call the project team. All of them would be involved in supplying the finished product or the finished system to a customer or an end user. Now, most of the folks watching this are probably fit into that customer or end user category. So these are all the people behind the curtain, if you will, that are involved in delivering this type of system to that final protected space. What are the different types of codes and standards that are out there in our industry? On this column, we've got NFPA codes. So NFPA codes are generally standards that are focused on the design, installation, and maintenance of these types of systems. There are different standards for different types of technologies, and again, focused on the design, installation, and maintenance of the types of systems that we're dealing with here. We also have a set of what I would call performance-based standards, or standards that look to provide guidance on how to test these types of systems to ensure that they're meeting a certain level of performance. Fire testing, for example, commonly associated with these UL standards, and a variety of other component type tests that ensure that those types of systems meet a quality level that could then be used in the industry. The bottom there, you see a couple of more European focused standards that are a bit of a hybrid. They include elements of design, installation, and maintenance guidance, as well as testing requirements and performance-based requirements, like we see in the UL documents as well. So a little bit of a hybrid, and folks in our industry deal with all of these standards all the time. Finally, the last topic I want to talk about is some regulatory activity that is occurring in our industry, particularly and specifically the AIM Act, which is short for American Innovation in Manufacturing. That was enacted in December of 2020. The AIM Act empowers the US EPA to establish a phase-down schedule for hydrofluorocarbons associated with the production and consumption of those chemicals. Now, that's a lot, that's a mouthful. This is a fairly complex and involved piece of legislation, as you can imagine, but I'll try to break it down for you in a couple of bullets, not easy. Essentially what it does is it allows the entities and the companies involved in the production and consumption of HFCs, allows them 90% of a baseline of that production and consumption in 2022. Now that baseline is determined from prior year's usage. So it's actually an average over a period of time. I believe it's 2011 through 2019. And then you take the 3 highest years of production and consumption within those 8 years, and then it's 90% of that baseline. So it's a fairly complex algorithm to get to that baseline, but essentially it's 90% of that baseline this year. And that reduces to 60% of that baseline in 2024. And then it further reduces all the way through 2036, where the last step is, I believe it's 15% of that baseline. So it's a fairly significant reduction in the use, the production and consumption of these HFCs through the next 15 years or so. So as you can imagine, that's going to have an impact on our industry for both manufacturers, local contractors, and certainly end users who are looking to purchase or install these types of systems. It will have an impact on both availability and pricing. So we would encourage you to check with your local installers, check with your local experts, or check with the system manufacturers who are dealing with these types of systems to see what type of impact or issue you might have. So in conclusion, pretty straightforward. We definitely encourage you to identify the special hazards that you might have within your business. Consider the variety of technology and the functional options that you have to achieve the objectives that you want within those potential special hazard environments. There are a lot of them out there. We talked about some. Work with your local experts. These are the guys that really understand, the guys and gals who understand how to design, install, service, and maintain these types of systems. And particularly here in the US, we have a fairly robust network of designers and installers at the local level, but certainly globally, these companies exist pretty much everywhere in the world. Finally, understand the code requirements and the regulatory challenges that you're facing. As I mentioned, some of those systems may have some challenges with availability and pricing in the coming years. So we would encourage you to take a look at that and make sure that you're satisfied with whatever selection you make based on those potential issues. Real quick, a kind of a explanation and a view of FSSA. As I mentioned, we are a nonprofit trade association. We're made up of manufacturers, installers, all folks that I mentioned in the project team, if you will. We've got about 184 member entities. We're dedicated to this industry, highest level of safety, reliability, effectiveness, and education around these types of systems. I encourage you to take a look at the website. We've got a ton of technical guides, training resources, all types of information available on these types of systems. And we hope you can utilize that to help make the best decisions you can around these types of systems. So with that, I am at my time. Thank you very much for your time and your interest in special hazard fire protection. And we hope this was educational and helpful for you. Thanks a lot.